Okay, hello, everybody. This is what do you call it? Our level up mini hack recap. So we have a few of our winners here. We have 10 winners. Not all of them have been announced yet, but it was relatively short notice as well. It's not, unfortunately, not everyone is able to join, but at least hopefully from our three lovely guests here today, you can get a little bit of a taste of the really interesting projects that were built. So I guess quick introduction. Hi, I'm Emily. I lead the DevRel team here at Scroll, and I'm just really excited to show off kind of the projects that were built. For context, this was built in celebration of, Alchemy hack, Alchemy partnering with Scroll. And it was a week-long hackathon. We're looking for like ideas that we had not seen that often before. So I guess again, congratulations to everyone. We had 62 submissions, um, a couple hundred registrations, which was a lot more than I expected for an online hackathon that we kind of announced off the cuff. So thank you everyone for joining. I'm going to go ahead and kick off Vedant and Regis, and we'll start with you, Adam. So Adam, I guess this time is for you. If you're like ready to share your screen, talk a little bit about your project, we'd love to see it.
Okay, thanks, Emily. I'm going to share my screen now.
Yeah.
Give me a second. Let me see if we do this. Okay, I'll just share the window. 1 second. Let me know if you can see this.
Yes, I can.
You can see Liquid Markets there, yeah?
Yeah.
So, hi, folks. This is Liquid Markets. Liquid Markets is a marketplace for buying and selling points, marks, or otherwise illiquid token positions. So I've one market deployed here on Liquid Markets, and it's for Scroll Mark. So anybody who's been using DeFi or Scroll over the past while will have noticed that for airdrops and stuff, there's a lot. We're now using kind of points programs where we build up points over time. And in the case of Scroll, we've been all using different DeFi protocols on Scroll, and we've been building up marks. And we're hoping that over the next while that there will be a Scroll token, and that our marks will be transferable into the Scroll token and a liquid Scroll token. But as it stands with marks, they're illiquid, so we can't buy and sell marks. And what Liquid Markets allows us to do is allows us to create offers for those marks and have counterparties buy them off us. And the way that works is that we create offers here on this create offer form. We say the number of marks that we want to sell, and we say the total amount of ETH that we want to sell these marks for. Okay, and when we create that offer, we not only say that this is the amount of marks that we want to sell it, or sorry, this is the amount of marks, and this is the amount of ETH that we want to sell it for. We also have to pass that amount of ETH into the contract, kind of as a booking deposit to ensure that we don't renege on the offer later. So you'll see there's a few offers here that are being opened up by people, and I can accept one of these offers. So I'm just going to accept this. I'm going to accept this one here if I have the second there. So I'm going to accept this offer here. So you can see that I'm actually purchasing this offer. So this offer is being created by somebody else for 1,000 marks for 0.1 ETH. I'm going to say confirm that there. And what happens is once that offer is confirmed, once the transaction has gone through, it'll go down here into my buys and it'll say that I've accepted it. Okay. Let's give that a second for the transaction to go through on Scroll Sepolia. So there you go. So you can see now that I'm after purchasing these amount of marks. And what the flow of what happens here is that this has now been accepted. The agreement is kind of, we've both agreed upon this. The seller has passed 0.1 ETH into the contract. I've passed 0.1 ETH into the contract. And when the Scroll TGE, the token generation event happens, this seller will then claim their Scroll tokens. They will pass them into the contract, and they will get 0.2 ETH back out, which would be their booking deposit and the purchase price that I've passed into the contract. And I, in turn, can then come over and claim my Scroll tokens. And just to show you how that works, I've actually sold 2,400 marks for this amount. And if I was to, I'm going to just check my wallet just to see. I hope you can see my wallet here. So I have a 0.199. So when I settle this, I should get 0.004 ETH back out. So you should see this should see the balance of my wallet going up some here. I'm going to settle this. So what I've done is I've actually deployed a mock scroll token, and I've minted some of it to myself just so I can demo with the settlement functionality. So I'm going to settle this here, and it should prompt me to allow, or to approve, I should say. So to approve 2,400 marks, or scroll tokens, I should say, into the contract. What I'm saying here is, here's the scroll tokens that we've agreed that I will sell to the buyer. So I've approved them to the contract, and now I'm going to transfer them into the contract with my second transaction. Here we go. And this is transferring them into the contract. And the contract will hold these scroll tokens until the buyer comes along and claims them. There you go. So that's now gone. And if I look in here, I should have a slight bit more ETH in the contract. So there you go. So I'm after getting 0.004 ETH back out. And that's what's happened there is I've got my collateral back, and I've also gotten the payment back, and I've transferred the scroll tokens into the contract. I'm just going to switch over to my other wallet here, which will show you the claim functionality. Switch over here. So this is the counterparty to that deal. So I go here. Should see down. Let me see.
Oh, are you sharing your browser? I feel
I'm
like it doesn't
showing.
show your MetaMask, but I mean,
It
that's
doesn't show me MetaMask.
yeah,
Oh
yeah.
no.
Like I understand the concept of like you're clicking an
I'm
extension
sorry.
and showing up.
Apologies. Yeah, so I wasn't sure whether it was showing me MetaMask or not, but so that is out to go and show. I don't think I was the counterparty to that one there, but I'll just explain exactly what should have happened. I think I actually bought a different position, and I don't have the wallet for that one. Okay, but what happens when I settle that? It should show up here for 2,400 marks, and as you can see, I've actually already claimed these out of the contract. So a button appears here to say claim. I'll click that claim button. MetaMask will pop up. I'll approve the transaction, and I will get the scroll tokens out. So you can see overall how it works. And obviously I'm using it for scroll marks, so sell your marks, and later on you get scroll tokens. But the contract itself is points and marks, and it's agnostic to what it is. When you're setting up the contract, you decide what point system it is that you're looking at, or that you're selling and buying. So it can be used for other point systems. So it's not that, when the scroll TGE happens, that this is no longer of use. It can be used for any point system. And as we know, point systems seem to be here to stay. So it could be any protocol point system that you can use. It could be used for over-the-counter positions as well. If you could extend it for locked positions and so on. So there's plenty of functionality here. You can use for marks, you can use for points, but it could be used for over-the-counter positions. It could even be used as kind of a pseudo option platform, if you to speculate on whether you think that a kind of a token position will be worth more or less than your collateral and the buy price. So that's the gist of how it works. Essentially, it kind of escrows the ETH to ensure that people don't renege on their contract. Once the TGE happens, they pay their tokens, or their liquid tokens, or their scroll tokens into the contract, and the person is able to claim them back from them.
Very cool. So I was kind of wondering, what made you think of this idea, I guess.
So I suppose, I think we're all kind of, all of us that are included or all of us that are kind of, building smart contracts and building apps and kind of using DeFi and using blockchain all the time. You're probably always kind of thinking of different ideas that you kind of want to implement, and you're kind of, you're always going to have little, you might use a DeFi protocol and you go, you know what, I think this would be a good addition to this, and then you start building stuff for yourself, smart contracts. You say, not only do I think it will be a good idea, but I might try and implement this myself. So it kind of popped into my head as I was looking at, you're kind of, as I'm building up marks and stuff like that, and I'm using the scroll layer 2 and stuff like that. It kind of came into my head that everybody's counting these scroll marks, but it'd be interesting to see, if you could have some place to sell the marks and make them kind of semi-liquid, essentially. That's kind of how it popped into my head.
Yeah, that's interesting. It's
Yeah.
funny. I feel like everyone in crypto is like, okay, how do I make money on XYZ? No, I'm just kidding. Yeah. I guess to wrap this up, because we have quite a few people joining now. I guess we have like 4 or 5 projects. Piece of advice for like other hackers?
Piece of advice. I suppose when a hackathon pops up, I think, like, let's be honest, people immediately think, I'll go in for this and I'll get money and stuff like that. And I totally understand people's motivations behind that. But honestly, I always try and land, try and think of something that I think is cool, that I want to implement, and that I think, even if you're not successful in presenting it or in winning a prize or anything like that, something cool that you're kind of proud of and that you can present to people outside that, and that you might be able to use to kind of, in a career or something else. So I think that's probably what I think is, it's just build something cool, to be quite honest, that you find interesting, because otherwise you're just kind of, it's just kind of, it'd be a bit boring just building something what you think other people want. So that's,
Yeah, yeah. No, that's totally fair. I feel like hackathons are a really great place to test your skills and like learn
yeah,
and stuff like that.
yeah.
Okay. Well, thank you so much for joining, Adam. Very cool project.
Mhm.
I'm gonna kick you off.
Thank
So
you.
goodbye. And then I'm gonna bring on Synapse Protocol. Vedant, are you here?
Yeah, I'm here. Can you hear me?
Yes, yes. Hi. I guess if you want, like, please introduce yourself and then introduce your project.
Yeah, so I'll share my screen first. Yeah, so is my screen visible?
Yep.
Okay. So to start, Snaps protocol is a decentralized stability protocol. So it aims to provide stability to complex systems, and it is based on a fundamental theory called chaos theory. So what this theory tells us is like, if there are small fluctuations in a system, it can cause the system to evolve in unexpected ways, which can lead to chaos, but it also can lead to increasing stability. So, how does Synapse Protocol leverage chaos theory? So, each individual player is represented as a neuron smart contract. So, they interact with the system and do smart contract interactions on chain, which contributes towards the stability. And how we follow a neuron based architecture. So basically, each person or each user is a neuron, which is a smart contract, which can send messages. And neuron can send messages to a central synapse contract. So this acts as an entry point. Along with this, a neuron can also forward messages to other neurons, which can create recursive chain of communication, and it can also create complex interactions. And with each forwarded message, the system's entropy increases. So when the entropy increases, the stability also increases. So for example, we have a set of neurons and we have a synapse, a central synapse. So for example, A can send message to B. Also, A can directly send message to the synapse. And other case would be A sends to B, B sends to D, D to C, and then it goes to the synapse, which can create complex interactions. So this is our basic architecture where there is a synapse contract, there's a neuron factory which is responsible for deploying the neurons, and each application that needs stability is called a conduit. So for this demo, we have two conduits, a stablecoin and a Sudoku game. So let's go to the demo. So first, before starting, you need to create a neuron, which is basically a smart contract. So you deploy your own neuron. So we are using account abstraction through Alchemy account kit. And so let's start with the stablecoin contract. So in the stablecoin contract, we have certain values. There's a stability factor, and there's a current price, which is a mocked value of the Ethereum price based on the USD value. There's some total supply and the user balance. So let us start by minting some Synapse tokens. It's a stablecoin. So these are passkey based interactions. There's no gas needed. So once a token is minted, you can refresh this. And you can see we have increased the total supply, but we have minted the current stablecoin according to the 2050 price of Ethereum. So our stability factor does not change. So for example, what happens when we change the value of the current price? So for example, I do it 1900, we update the mock value. So like now the mock value is updated to 1900. So what happens with this is the current total supply is not in balance with the price of the oracle. So we see that the stability factor is decreasing. So what our protocol does is everything is a neuron. So multiple people can contribute to stability of this specific stablecoin conduit. So for example, I have this other account, and this neuron can also contribute to the stability of this. So we can contribute to this by supplying some Ethereum value. Or for example, this account doesn't have enough ETH. So like for example, from this account, I can contribute towards the stability. And once my contribution is successful, you can see the stability factor again goes to 1. This means that any neuron or any smart contract in the network can contribute towards the stability, which can in turn provide him some incentives and overall increasing or like maintaining the stability inside the contract. So, for example, the second example, which is a Sudoku game. So we have a certain entropy value, and it's a zero knowledge based Sudoku board. So there are some hidden tiles and there are some answer tiles. So people can guess the Sudoku board. For example, for this value, I can guess the output as 3 and play my move. So multiple neurons can contribute to the solving of this puzzle. So, for example, I did 3 in this interaction. After playing this move, it can either increase the entropy of the system or it can decrease the entropy. So, for in this case, it increases the entropy. This means the puzzle is more towards the completion, and at certain point when the entropy is at its highest value, we cannot go any further. That means the puzzle is solved, and you can prove the puzzle using zero knowledge proofs. So at the current state, the puzzle is not solved completely, so we cannot prove this. So this is basically our protocol, and it can be used by any application which needed stability, and it can reward users for incentives to maintain a stable complex system.
Very cool. So I think one thing that caught my eye here was like I had never heard of like or thought about stability. If you could give like maybe a one-liner on like why decentralized stability is important and like what it is for how it yeah.
So like last year, if you remember, there was Aave launched its GHO token. So initial days, the token value was not pegged at a dollar. It was about 0.979899. So what was the problem that many people didn't want to contribute to the arbitrage values because they didn't have any incentive. So you had to provide a collateral from the Aave interface to the GHO token, and most of the people didn't seem that it would provide enough value. So what happens is our protocol is we provide incentives to users to maintain a stability factor. For example, in the case of stablecoin, so if anyone gets an incentive, they are more inclined towards maintaining a stability rather than not maintaining it.
Yeah. Yeah. Curious how you came up with this idea. Like, are you a mathematician? Like chaos theory? Like,
No, so I'm an engineering student. So the main concept of the idea came across with the GHO token. So previously I was coding with the GHO token, and the main problem was it was not pegged to a dollar. But now for the GHO token, it's pegged to a dollar because they have introduced certain modules for stability. But the main idea was like to help make system stable, which was inspired from the GHO token.
very cool. And to end, one piece of advice if you had to give for hackers.
Uh, so like if you are hacking in a hackathon, so it's not about winning or losing. It's like for if even if you don't win, you can go to other people's project and see how they code or how they write code, which can make you a better developer overall.
Very cool. Yes, that's a good piece of advice. Learn from others.
Yeah.
Well, anyways, thank you for joining. I'm gonna kick you off, and I'm gonna bring our next hacker on. Uh, is it Regis? Do you pronounce it differently? But Cipher Scroll. if you could please introduce yourself and then give us a small walkthrough of your project. Okay. Hello? Are we having technical difficulties? I can hear you, yeah.
Okay, now it's working.
Oh,
Sorry.
no worries.
Yeah, so I'm Regis. I'm a software engineer. Do you see my screen?
Yes.
Yes, perfect. So yeah, I'm going to present you Cypher Squad. So we are a for cybersecurity learners. So usually when you're learning cybersecurity, you have like a platform where you have like a CTF. CTF stands for Capture the Flag. And so usually you have kind of basic challenges where you have like a flag and you need to understand how you can decipher it, or maybe you need to do some, I would say, learning intrusion where you can get the flag and put it on the website to validate, I would say, the challenge. And so here with Cypher Squad, we wanted to propose like a DApp where each challenges that you have done is published on chain. And so you can have a track of the different challenges you have done and have the possibility for maybe recruiters to be interested in your profile, and also maybe have be able to participate in some events based on those challenges. So here we have one. So for this demo, so here we will have a payload, and we need to understand what will be the flag for this one. It's a simple one. It's a base 64 encoded text. So we can take this information, so this flag, and submit it. And so basically behind the scene, what is going to be done is we are going to generate a ZK proof of the flag to, uh, to, to allow us to submit it on chain without revealing it, the flag. Else anyone else can just sniffer the network and take the flag and put it directly on it. And so here with the proof that I have done, I can verify it and send it to the smart contract. And then the smart contract will know that I have succeed this challenge. And so here, for instance, if I'm refreshing the page, here we can see that we have succeeded these challenges. So yeah, basically the idea of this app is to be able to build your reputation on chain. Mostly, I would say in cybersecurity. But yeah, the idea is to allow this tool to be able online.
Perfect. So I guess same set of questions for you. Do you work in cybersecurity or like I guess do a lot of
Yeah, I'm currently looking for a new job, but my last experiences was in cybersecurity. And yeah, so I'm kind of used to that. And also currently I'm learning like more in deep, smart contract. And I kind of using like open zipping challenges, I would say. But
Mhm.
I wanted, to be able to have that kind of similar Web2 application in Web3,
Yeah.
especially for capture the flag.
Okay, very cool. I guess yes. Not to sound like a broken record, but piece of advice um, for hackers out there.
Yeah, I would say we always want, to have a big project with big features. I mean, multiple one, and yeah, we said to decompose it in step by step to be able to do it. Especially for this one, I mean, I was not really familiar with Noir, for ZK stuff, and so this is where I decompose it to be able to have a product at the end and to be able to have a working demo that is possible. So my advice would be to decompose it and doing step by step.
Oh, so this was your first time using Noir.
Yeah.
Very cool. Well, I love that, hackathons are a place for experimentation. Anyways,
Yeah,
thank
exactly.
you go so much. We're gonna just go down the list, and I'll kick you off and bring on Michael. Hi, Michael.
Hello. Can you hear me?
Yes, I can hear you.
Awesome.
I guess same.
Yeah. So
Introduce yourself and your project.
yeah, I'm Michael. I'm kind of a pseudo anonymous, kind of, because obviously you know my name and such. But yeah, just for the public, yeah, I'm Michael. I participated in this hackathon. I started kind of in the middle of the week of the hackathon. Uh, So I decided to make like a simple project. It's a simple project. It's kind of, it's not really, it's kind of, it's not really like an utility, like something that you really use. It's more like a fun thing, fun thing. So I'm gonna go ahead and share here my screen. So I'm just gonna show right away. Okay, this is it. Okay, can you see here
Yes.
my screen? Okay. So essentially, this is a collaborative canvas. I got this idea from like a really old websites, like really old, like I think 2013, 14, something like that, where like you could buy pixels with Bitcoin of a canvas. Like people would like paint their brand, their website, like their logo, for example, of their business, and that would kind of be like an advertisement. So people would like compete into painting their logo or whatever on the canvas, because anyone can paint over your pixels. So everyone was always doing that, and yeah, it was kind of like that kind of concept that was like a public canvas. Anyone can write on it. And yeah, so I wanted to make like something like that, and here it is. It's essentially that. Like you can paint anything. Like as you can see, you can like choose any color here, paint anything. You can go ahead here and choose an image to paint here, and it will work. Let's see, like a cat, for example, and you press one corner and then the other corner, then apply image, and here it is. And then it shows up here the pixels that were selected, or the pixels that the image is using, and then you press the purchase selected, and then it will tell you how many like how many paint tokens you need to paint the pixels. So my idea here was like to if you want like to paint like in this case like over 2000 pixels, you need 2000 of the paint token. There's like a token, an ERC20 token, and then you need to paint to buy that paint token, and then you spend those paint tokens to paint the pixels. So I'm going to go ahead here and buy those paint tokens. I'm using scroll the testnet here. It doesn't simulate, so it just shows this here. But yeah, I'm buying them. And by the way, this is already like it's on the mainnet. I can just change it here. But yeah, I'm testing it right now just to show you. So I bought like the number of pixels here. And now I can spend, essentially, I spend the paint tokens to buy the pixels. For each pixel, it's a paint token. So like, since it's a lot of pixels, in this example, there's like a lot of transactions that I need to make. So I'm going to go ahead and maybe paint like a smaller cat, actually. Or maybe like something here. Like, this, whatever, it was supposed to be a square, but now it's this. So I still have these paint tokens, as you can see, like it's an ERC20 token. I can transact with it, do anything with it. And now it detects like I want to paint 18 pixels, so it detects that I need 18 paint tokens. since I have way more than that, it says that I have enough. So I just press paint pixels, and it opens up the transactions here. This first transaction, actually it's not, but it will technically still like ask me for approval to spend the tokens. But I think this in this case I don't need it because I was already messing with this account. So yeah, I'm just buying them, and it's done. Like they're here, and I can like reload the page, and they're here forever. Like the pixels are directly on the contracts. It's not like NFTs where it's like you put like a link to like an IPFS data and then it links that image. No, like every pixel here, it's on directly on the blockchain. So that's it. And it's like on the mainnet right now. I think like one guy already painted. Like I painted this and I painted this. I guess someone painted this. Like this
That's funny.
square.
Yeah.
And yeah, that's it. And like when like there's a limited number of paint tokens, and when I paint one pixel, I spend that paint token, and that paint token is burned. So essentially, there's 10,000 unburned paint tokens that after those tokens are all spent, the canvas will stay like it is forever, essentially. Um, so it will be kind of like an immutable image, kind of like an NFT, kind of similar. So yeah, it's on mainnet. If you want, you can try it out if you want. And yeah, that was the project. It's really simple, kind of fun.
Yeah, no, it was a super fun project. This is a bit morbid, but I went to an NFT gallery once, and this reminded me of a project where the artist, so the NFT artist like changes the NFT art. I guess you buy an ever-changing NFT art from this artist, but it stops changing and becomes immutable once the artist dies. Not that it's the same, but like the same idea of like, oh, this keeps changing over time, and then at
That's
some point when you
interesting.
hit 10,000,
Like you need like some sort of like oracle call to set to know if the artist died.
yeah, it's a really interesting kind of um, setup. I don't know, but that's art, I guess. But yeah, I mean, fun project. It's cool that this was inspired by something you're familiar with from Bitcoin way back in the day.
Yeah.
Yeah, so
Unfortunately, I didn't buy like many bitcoins. I was really young.
yeah, unfortunately. But yeah, I mean, any word of advice for other hackers who participate in hackathons?
Um, I don't know. Like I guess try to make like something useful that maybe later you can use,
Yeah.
and don't spend too much time on the details, and then just ship as fast as you can to see if it gains traction. Like for example, in this case, like you mentioned, if this had some success, um, then when that happens, then you should polish it. But like try to see if people are going to use it. If it's really actually like something people want.
Yeah, for sure. Well, thank you so much for hacking and thank you for joining. I'm going to bring up our next person here. And I think this is our last, I guess, participant who was able to join us today. Is it Hamid?
Hi, yes, my name is Hamid.
Nice. Okay, cool. Um, please introduce yourself and let's jump into your project.
Oh, okay, great. Okay, can you see my screen?
Yes.
Okay, great. So my name is Hamid, and for this hackathon, I'm presenting my project called Sinule, which basically translates to sign it in English. So for this project, we're basically exploring signing documents on chain I'll tell you my motivation for building this project. So a while back, I was on holiday in a country and I wanted to sign a contract. Unfortunately, the platform that I was supposed to sign my contract on did not support the particular country I was in. And I found that very weird. Like, why should my geographical location prevent me from accessing a basic feature, right? So which was why when I saw the opportunity at this hackathon, I decided to leverage on Scrolls Network to basically create this. So as you can see, it's basically for making signing documents effortless. It's essentially imitates the Web2 alternatives that are available, but adding a touch of Web3. So for example, you can just come on here, you can click on create a document. Basically, for you just type this, the name of the document, add a few description. I could say for example. Right. So assuming I have an idea with him, so next thing is to just upload the file that you intend to sign from your system. So I'm just gonna search for this. Yeah. All right. The next thing is to impute the signer's information. So it could be their ENS name, it could be their wallet address or base name. So for this, I'm just gonna select a wallet address. Yep, this. And the cool part is I could actually send to multiple people if there are multiple signatures required. And then I could also add their email address, for example, just so that they can get a notification when the document is added. Then click on create a signature request. So once you click on this, it's going to basically just pay a little gas fees for this particular transaction. Yeah, so you click on confirm. Yeah, you get a notification that your signature request has been created successfully. So right, so basically, I'm going to switch users now, so I could see, so you can see what the signing process is like. Okay, so so I just do switch to the address. Alrighty, yeah. So I switched address now. And if you go to pending signatures, this is where you see the pending document. And in here is the one that I just recently created. So I could see the creator, I could see description, and then if I click on sign document, it's basically going to load up the documents. Yeah, I'm just it's basically going to load up the document as you can see here. And if I'm satisfied with what I've seen here, I could just click on sign. So once you click on sign, it's going to load up the canvas where you can append your signatures, and then successful transactions are submitted. So because of network connectivity, I'll not be able to demonstrate that at this time. But basically, once that is done, everybody is notified, both the signee and then the originator, the creator of the document. And basically, the document is marked as complete and it will be filed under your all document here. So for example, this is a completed file, for example, that's been completed, and you can view it. Similarly, for signed document as well, you can also view as well. So basically, that's the overview of this particular project.
Yeah. I didn't realize documents were gated geographically. That's very interesting.
Exactly.
So I'm sorry you had to go through that, but thankful that you were able to come up with this idea from it, I guess.
I mean,
Yeah. Cool. So you are our very last presenter. So as our very last, you also get to give our very last piece of advice. Um, what do you think is important for like a good hacker experience?
oh, for a good hacker experience, I believe we should leverage the tools available at the hackathon to just solve problems that either been on your mind or problems that you're currently facing. So that way you derive some sort of satisfaction with your product, even if you do not win a prize or anything, but you be satisfied that, oh, wait, I tackled this problem with this tool and I was able to achieve that. Yeah.
Awesome. Perfect. Well, thank you so much for joining. I guess that's everything for now. So goodbye, Hamid, and goodbye, everyone else online.
All right.
Um,
Thank you very much.
yes, thank